Hello, and welcome to AV Cyberactive. In this course, I'll introduce you to cryptographic failure attacks that compromise sensitive data, as well as how to classify sensitive data using a variety of methods. Next, I'll examine how to hash files in Windows and Linux, along with various methods of file encryption with Windows devices. I'll then explore the PKI hierarchy and also how to use a certificate to secure web application with HTTPS. And lastly, I'll go through how to configure IPsec, encrypt cloud storage, and mitigate sensitive data attacks. Let's get started. One of the OWASP top 10 items in cryptographic failures is that it can result from either the lack of using cryptographic solutions, such as not using encryption to protect confidentiality of the data, whether the data has been transmitted over a network, or whether the data is stored or used in integrity to ensure that the data hasn't been tampered with, that it's authentic and it's accurate. But a cryptographic failures that can result in a use of weak cryptographic solution like WEP, WPA, or Wi-Fi. Over time, cryptographic solutions become obsolete. They become deprecated because they are not known. They become known and vulnerable to attack. And so it's important to make sure that we keep up with the latest cryptographic solutions such as Wi-Fi or storage on disk. Another aspect of cryptographic failure could be insufficient security controls to protect the secret or private keys. Now, a secret key or a private key is often called a symmetric key. A symmetric key means that the key that encrypts is also the key that decrypts its own key. I've made a different video on that one. But with the public key cryptography, you have a public and a private key pairs that are mathematically related and that are issued to the users or devices and software applications. The public key can safely be shared with everybody, and that's why it's called a public key. But a private key is not that easy to get hold of. That's why it's kept secure. Only the owner of the private key can have access to it. So you've got your private key file here, stored on the thumb drive on the USB and encrypted. Now that's not safe to store the cryptographic key like that. Encryption provides confidentiality. In our diagram on the left, we have some plain text. It says that a quick brown jump fox over the lazy dog. When you encrypt something, what you're doing is feeding the plain text into an encryption algorithm, essentially to complicated mathematical formula, but you're also providing a key as well. And the result is what is called a ciphertext. It is encrypted or scrambled data that you need to correct the key. You need the correct key to decrypt the ciphertext to reveal the original information. For security reasons, over time, it is important for periodically change or rotate the keys. In case a key is sometimes compromised, you might want to make sure that you are changing it on some time on a frequent basis. But encryption is not really only with a cryptographic key solution. Hashing as well. Hashing provides integrity. When encrypting data provides confidentiality, it means we can ensure high data integrity for messages are sent over a network. It can also provide a secure method of storing passwords by storing hashes as opposed to storing the actual password itself. Hashing can be used to detect file system modifications. It can also be used with encryption so that encryption provides the confidentiality. But hashing can be used to verify the integrity of the message. So to make sure it hasn't been tampered with and it is authentic. Interestingly, hashing is non-reversible like encryption. With encryption, if you have the correct key, you can decrypt and reverse process. There is no key that is used for hashing. So it's non-reversible. Here we have an example of hashing using PowerShell. Specifically, when you get a hash file cmdlet, you can then provide the path of the file name, and then it will result in a hash value. It's a unique value. In this case, the output tells us that the hashing algorithm that was used here was SHA-256. That's the secure hashing algorithm here. Now, if you run the same command, the figure, and let's get a different hash value, it means that the file has been modified. So with hashing, the data is fed into a hashing algorithm, a key isn't needed, and the output is a unique fixed length representation of the output data. What that means is that regardless of how small or big or large the amount of data is, you're hashing and you will get the same length of hash value, such as 32-bit hash value. Now, that hash value can be called the hash or the hash value input. It can be also called sometimes message digest, and when the data is modified, you can generate the hash in the future. The hash will be different, which means it's a indicator that something has changed. Hashing can be used for file integrity monitor or FIM solution to detect if the file has been tampered with by unauthorized users. The standard for Linux password is that they are stored in an etc shadow file. In the screenshot, you're using the sudo command, and run an elevator privilege command, you're using the tail to show the last couple of etc shadow commands. What we have, for example, here is that the user with the name of Utvo. After that, we have a colon here, and then we have the password hash. There are some other items at the end of the represents the password value. So the users so the user password can then be hashed and then can be stored in etc shadow. So when the user signs in entering the password, it gets fed through the hashing algorithm. It should generate the same result, which means that it is authentic. Now, to make hashing a little more difficult by malicious users to crack, you can also use salting. A salted password means that there is a random data that gets added to the password at the end. Otherwise, it'll be easy to crack unsalted hashes. Using it is something that's being used is called rainbow table. Rainbow table can sometimes have a couple of forms, which are generally speaking it's like a lot of pre-computed hashes that can be compared. For instance, etc shadow file. This is the thing with the rainbow table. It's a list of pre-computed hashes, and it shows the source taken resulted in the hash. So it would always have to determine what password is. Cryptography can be used to store and protect the data at rest using self-encrypting drive SED, or by using Windows EFS encrypting file system, or Microsoft BitLocker, or even cloud or the third-party solutions can also be used. So there are many choices available to encrypt the data at rest. When Microsoft EFS is getting used, it requires NTFS file system on the correct Windows edition. What that means is that if you're using another instance of Windows 10, Windows Home Edition, it does not support EFS or BitLocker. So certain editions don't support these feature. With EFS, you can choose to encrypt in individual files and folders, and those encrypted files are tied to the user that is logged in. And then the user, when encryption was enabled, you have to be signed into that user to decrypt and and it is very transparent. In other words, user just opens the unencrypted file as usual. You don't have to do anything special decrypted. EFS can be managed. EFNs can be managed using the Windows GUI, so settings can be managed at the larger scale using group policy, or at a command line using the cipher.exe, such as cipher/e to encrypt something, or cipher/d to decrypt something in the Windows GUI. So when you go into the resources properties file, such as been done here, if you click on the advanced, you will see at the right and bottom it will open advanced attribute in the bottom. You can choose encrypt the data. Microsoft BitLocker is a little bit different, because instead of getting to encrypt individual files of the folders, and BitLocker is designed to encrypt the entire drive. So whether it's a hard drive or a fixed drive or removable data, such as thumb drive, you can also require it to use a pin to decrypt that disk volume, such as the operating system. So someone would have to enter the pin. So after booting, you can continue on the machine with the operating system to encrypt with the BitLocker. BitLocker can be used as a trusted. It can use TPM module. The TPM is a firmware chip that is used to store cryptographic keys on the machine. It can be used to verify the startup environment of the machine hasn't been tampered with. BitLocker, like EFS, can be managed during the GUI and in the GUI, and using the group policy using to manage the BDE command. The BDE stands for BitLocker drive encryption. So there are many things we need to think about the outside the web server stack, outside of the web application details, to make sure that the web server files that might contain sensitive information such as databases are properly encrypted and protected in the backend. You can't discuss web application security and cryptographic failures without doing an overview of the certificates, or the PKI. PKI is a big deal in reality. It's a hierarchy for digital security certificates. The hierarchy enables what's called the chain of trust. What this means is that it is in the top of the hierarchy. If we have a certification authority or a CA that issues certificate by trusting the authority, that issuer of the certificate, by extension we trust the certificate that it has been issued. And this is important when client devices connect to a website that uses HTTPS, because you can't have an HTTPS binding with the server without having a PKI certificate on a web server. So certificates then are issued by the certification authority or a CA. You can have a public CA. What this means is that issuer of the certificate should be trusted by the other user devices, whether it's an iPhone, Android, tablet, Windows, Linux, Mac, computer, whatever it is. Computers have it in built-in certification authority that they trust in internationally, so that they, when you visit the website or the web application that uses one of these certificates issued by a trusted authority, your machine will trust that certificate. Otherwise, you get a warning message that a web browser to not proceed without the certificate not trusted. That would happen if you and if you had a private internal certificate authority or CA where you have issued your own certificates, unless you install the PKI public key certificate of your CA route, your devices would not trust the certificates that has been issued. So, certificate authority or CA can issue PKI certificates to individual users, maybe for the purposes of encrypting file, for sending email messages, or any other case. Certificates can be issued to devices such as to allow authentication to a VPN or to an HTTPS binding for a web server. Certificates can also be issued to a software service or a principal to manage in principle to manage the identities, to allow them, or perhaps to authenticate to other components that might need to talk to. When a certificate is issued, one variance of its wildcard certificates, and this would be referring to things for securing web servers with HTTPS. For example, imagine if we have a wild certificates called *mydomain.com. That means that we would have HTTPS that would be enabled and work correctly for mydomain.com, for sales domain, for accounting domain, and whatever it is. You wouldn't need a separate certificate for each of those identities or entities in this case. Then there's this notion of extended domain validation certificate. This means that the certificate authority must be doing their due diligence or to do extra and checks to ensure the legitimacy of the certificate request, such as verifying that the registered corporation and so on. There's this notion that the code signing of a certificate, so that when a software is developed, such as an application that will be presented in the application store, properly issued code signing certificate is usually used to digitally sign the code and or the software or the application that is trusted by the other devices. You can also use a code signing certificate to sign in something like a script, a bash script, or a PowerShell script. There is a life cycle of certificates. And the first thing happens is that the certificate signing request or a CSR is generated, and then a public or a private key that are generated. The CA then will issue the certificate such to the user. Now these steps can be completely be manual or they can be automated. It depends on the solution that you're using. Then the certificate gets issued. The certificate potentially might have been revoked, such as a certificate on a smartphone or a VPN, and a smartphone is lost or stolen. The certificate on that phone can be revoked essentially or by the admin, so it can be used. So it cannot be used. Certificates can also be renewed before they expire. Otherwise, if a certificate expire, a new one would have to be issued. kind of like a driver's license or a passport, you know. So certificates are created from a certificate template. The certificate template is used when the certificate is issued, and it contains things like an encryption algorithm and the digital signing of algorithm that's used, because each certificate is signed digitally and is by the certification authority. That's a part of what establishes a chain of trust in a PKI hierarchy. The certificate template can also specify certificate usage constraints, such as the fact the certificate can be used to only encrypt. So within the PKI certificate, you would have the subject name. It might be an email address for a user. It might be a fully qualified domain name, DNS server, or whatever it is. You would have to change the certificate usage by details, the issuing CA name and the digital signature of it, the date of the certificate was issued, when it expires, and all of those details. So when it expires, it can no longer be used. The public key is actually a part of PKI certificate. They The related private key is kept in the operating system secret storage location. There might be other attributes added to the certificate as well. Now, a revoked certificate, which we have discussed in the life cycle, we can use the certificate revocation list or CRL protocol. So this is often just called a CRL. What happens is that when a certificate is revoked, a serial number can be added to this list. Any parties participating in the PKI hierarchy can download this revoked serial numbers. An entire list of downloaded can be checked locally and look for an invalid certificate that they are trying to use. So maybe this would be done, for an example, periodically to schedule a web application. Another variation of this is online certificate status protocol, or OCSP. The difference here is that individual certificate in question, its validity is being checked when it's being used. These days, personally identifiable object information, shortened for PII. PII is all the rage when it comes to web application security. It's absolutely critical that we have a proper assessment about the type of data that might be input to a web application, how the data has been processed, and of the resultant output of the data. Is it sensitive? Is it PII? So what is PII? PII is really information that can be uniquely identify an individual. It could be one or more than that piece of unique sensitive information. When put together, links back to an individual. Now, there's a lot of data privacy related issues these days. There are laws and regulations and security standards. Depending on the nature of your business, you will have to adhere to things. That if you have a finance industry versus the health industry, if you're dealing with European citizens, there are regulations like GDPR. Now, GDPR, it will affect regardless where your web application is located. We're talking about data privacy for the collection of data. Often sensitive data must be located with the consent of the data owner. The transmission of the data needs to be secured, such as over an HTTPS connection. Then there's the fact of storing sensitive data where it's being stored at all, or whether it's been encrypted when it is being stored, and where it is located. In some cases, for example, you are a Canadian company, and with the Canadian citizen sensitive information, that the information must reside in the servers with the Canadian national boundaries. Data privacy also applies on how it is being shared. If it's allowed to be shared at all, then in that case, then it ends the right there, how the data is being used. If it's being used to generate statistics, for example, the data can be anonymized. So you would still have, for example, an income of certain demographic people, but you don't need to know the details of the person's name, social security number, and all of those details. If you're in the United States, you wouldn't need to know the street address. You just need to know their income, and so it can be anonymized by removing the sensitive information for the purpose when it comes to usage. All of this falls under the umbrella of PII. The non-technology examples of PII would be like your mother's maiden name, your street address, credit card number. They are all very personal details, but you just wouldn't want to wish to give it to somebody else. On the technology side of things, PII Examples would be like your IP address. On the right context of your IP address can be considered, a PII. A cookie or a web application where a browser might contain sensitive information for authenticated session. A trusted web application, an electronic medical record, otherwise called EMR, is sensitive information. Now, take another information where it is called the sensitive personal information, or SPI. It might not link to an individual. When it is being tied to an individual in some context, it can be a negative connotation. Some people don't want to share this type of information, like your political affiliation, or if you have one at all, your sexual orientation or your gender identity. If you are a member of trade union, sometimes people don't want to share this information. Other things would be like your religious belief, your religious authentication, orientation, and all of those. On the medical side, we have reported, PHI. It is similar to PII, except that it deals with the medical industry. If you are dealing with the regulations like HIPAA, and then that would be really be focused on the medical industry in the United States. So PHI deals with both past and current health information. It might include information about future health related, details of your healthcare, payment plans, insurance coverage, like these. So web apps that deal with this kind of information need to have the appropriate security controls in place to protect it. You need to have periodic security controls audit related to these things, meaning that you should periodically review the organizational security policies that might dictate how this data is to be used, treated, and how it is to be secured. A periodic security control audit will allow you to evaluate the efficacy of the existing controls that might protect the data, and it might reveal that you need to replace the security control that was once effective and no longer is effective now. You might modify the configuration of an existing security control, so it lets us identify the security inadequacies that and implement security control changes as required. We have already discussed the importance of PII, or many types of the sensitive information that needs to be protected as a technician securing the web application. So you need to be aware of the laws and regulations they apply to the web application you are managing. Now let's talk about the data privacy standards. Now these often will drive the details within the organization's security policies, such as what type of data must be encrypted, how long should it be retained in terms of backup archives, and so on. Now, data privacy standards are also important because for legal regulations and even compliance purposes, even for contractual obligations with certain business partners, you might have to have a certain security control in place. There is a tight knit relationship between the security and regulatory compliance in this IT world. Think about the things like sensitive information, like confidentiality, which means encryption. So, encrypting over the network with HTTPS, maybe encrypting backend databases, read from and within right to a web application, and integrity, which can be done with the things like file integrity monitoring to detect unauthorized tampering of important files and data retention requirements, depending on the nature of your organization and your agency. You might have to follow some certain types of documents for a specified period of time. You might have to be legally be bound to these documents and incidents that occur because of these type of infrastructure related issues, or that might be dealing with the customer patient sensitive information. Sensitive information types would include personal PII, as we have discussed, that in the sense of one or more pieces of information that uniquely identify an individual. We also have the type of sensitive information like electronic health records and EHR, that is essentially a record keeping of patient's medical history that could be shared across different medical systems, whereas an electronic medical record, or EMR, is usually more localized to a specific medical clinic or doctor's office that stores the patient information. And then, of course, there is personal health record information, or PHR. It is entirely in the control of the patient that they have full custodianship over the personal health record, that we have the Insurance and Portability Act, that is HIPAA, otherwise called as HIPPA. Now, this is the legislative duty of the legislative act of the United States. So it is designed to limit the disclosure of the protected health information, so PHI or electronic PHI in the United States, specifically HIPAA related entities such as the healthcare providers. Now, any organization dealing with health plans for individuals also gets covered. HIPAA specifies physical as well as technological safeguards of protecting, sensitive medical information as related to European Union or EU. We have the GDPR, the General Data Protection Regulation. So this really relates to citizens in the European Union. It puts control of the data on their hands. So it is all about the data privacy being how the privacy can be controlled using PII. The collection and retention of the data and the use of it, the potential sharing of it is also getting controlled. What's interesting about GDPR is that it applies to the organization regardless of the location of their located in the earth. So if they're dealing with EU citizen information, then GDPR applies. So EU citizens must provide consent, and they will have full access to the consolidated information so that they can correct if they need to correct it. And this needs to be rectified immediately if the organization customer asks for it. Now, organizations that deal with EU sensitive information such as web application must comply with GDPR. Otherwise, these would incur fines that go up to millions. Then we have the PCI DSS. Now, this is one of the international security standards that deals with the cardholder information, that each specify what type of card, whether Visa, MasterCard, or any other type of card, that must, or certain types of debit cards have their own specific security recommendation. But generally stated, PCI DSS deals with providing a roadmap for merchant security standards that would be a merchants or organizations dealing with sensitive cardholder information. Some examples of PCI DSS would be to build and maintain secure network with very general statement. Now, PCI DSS doesn't outline specific details, so we might implement security control to address that goal by implementing firewalls, changing system defaults, and so on. If the PCI DSS goal is to protect the cardholders' data, we might put an place storage encryption at any time we store the cardholders' data if we are restoring it. So PCI DSS recommends that we do not store unless it's required. What might also implement is the network encryption in our networks. So if the goal is to maintain vulnerability management program over time, we might have antivirus solution in place, including updates. So when it comes to web application design, we might apply security controls to all software lifecycle or SDLC phases. If the goal is to implement strong access control, perhaps only grant permission who need to know basis to the cardholder data. We will ensure that all the system users that they have their unique user account for audit and accountability reasons. We might put in place security controls, for example, limiting who has access to the server room or wiring closet where storage array exists. In this demonstration, I'm going to classify on a Windows server or using a Windows file server resource manager. See, that is short for FSRM when it comes to the literature. If you would do a web search of typing that thing, so the idea is to classify data is for what you know where our sensitive data exists, whether it be on premises, on the cloud, or hybrid of both. We need to know where our sensitive information is, or in order to apply security controls to protect it accordingly, such as with encrypting your cryptographic solution or to protect the data at rest. You could encrypt everything, but it usually is not feasible. You might want to gather up sensitive data stored in a centralized location and encrypt that location, whether it be some kind of a vault or hardware solution level, or whether it be a particular disk partition, entire disk partition. So let's get started with the Windows server here. I'm going to open up my start menu over here in the server machine, because the server manager is one way by which I can install server components. FSRM is not installed by default, although it's available to be installed. So under configuring the local server, I will add the resources and features. I'm going to start for a moment here and fire up Windows PowerShell, because if you are in a command line type of person, you could also use add Windows feature cmd let or install Windows feature. It's all the same. and then give it some name of the feature if you want to install, such as the file server manager. Now if I get feature command resource again, here's the file server resource manager. The actual name is FSRM, but notice that it is not installed because we have an X within the square bracket, so I'm going to minimize that. I'm back here in the server manager. I'm going to proceed with the wizard again. The current server on which I'm doing this is selectable, so that's where I want to install the feature. Okay, that's good. Next, our roles. What I want to do is expand the file, file storage device in which within that, and I will expand the casue services because that's where I'll find the file service resource manager. I'm going to install and put like a check mark on there. I'll let it pop up. If it asks to install the additional tools, I'll just go ahead and choose add features because I do not want that. I click next, and there's no features I want to be enabled here beyond what I've installed for the role of services of file server resource manager. So I'll go ahead and click next, and I'll proceed clicking by starting. Before too long, the installation will have succeeded, so I'll close it out here. So let's go back to the PowerShell for a second and go up an arrow key or bring up the previous command, and notice in this time the FSRM shows being installed. Okay, so back in the server manager GUI, I could also go to the tools menu where I'll now show the FSRM option because it's installed, but it's not been configured. So I could go to the start menu under Windows Administrative in the same tool way down below, down in the F. So I could go to the FSRM. I'm going to start the tool. When I'm interested here, what is the classification management module. So you've got other things that you can do in this tool, like setting file system quota and file screening control, which types of files allowed on the server, run storage reports, and all that great stuff. But not that what I want classification management. So I'll go down under the classification properties. There are different properties that are available here. I can assign files and folders into them. For example, if I were to go to the file system over here, if I go to E drive, then I've got my sample files, and I've got the file sample file 2 here in the text, and it says that this is secret stuff among the other things. Well, if I wanted to go manually classify, and by right clicking on it, properties, options, and I'll have installed the file server resource manager at the classification option here. Now I want to create the new property, so I'm going to choose to create local property over here in the far right. Maybe it's called the property confidential. Now I've can either type a yes or no. Yes, it's confidential. No, it's not. It could be a date and time number. It could be a string or multi-string value. In this case, it just says yes or no. So I click OK. Now the credentials show up in my list of the local properties of the file classification here on the file server, and only on this file server if you've got a bunch of files servers joined at the same time. Active Directory domain, you can also define properties certainly here. That will show up. We'll look at the moment that let's look at the first by going to the file explorer on the file server. I'll navigate to the E drive sample. Here I've got a file, let's say sample file 2. I can manually classify the file by right clicking on it, go to properties and go into classification. Now the confidentiality level shows up in the local property of the server, but it's not set to yes or no. If it is confidential, I would choose yes. Now of course you might want to write a script that looks like these type of attributes, move them to a centralized storage location where they will be encrypted, or whatever mechanism you have in place to deal with that. There are many options, but it's doubtful you would want to go through them, all the files in the environment, and manually determine in this case if they're confidential or not. They must be automated in a way, of course. There is a way. And if I go back to FSRM, that's where the classification rule comes in. I'm going to right click on create a classification rule. I'm going to call it see confidential data. I'll click scope, so I'll choose the certain type of files, or down below I could click the add button and specify the location where I want to go. Here I want to specify the drive letter E, so I want to score drive E in its entirety. I'll choose the file or folder drive E, but I'll choose the root folder drive E. I'll click OK, and I'll click on the classification tab. I'm going to look for the content, which within the files I can select the property. I'll only create the one that called confidential and set the value to yes. Okay, but based upon what the condition, well, that's where the parameters and the configure button down below we are here for. If I click in configure, I can tell that if I want to look for string and it can be case sensitive or not, and I want to look forward for the word secret, and if I want and if that word is found, that will be flagged as confidential. Yes, I'll click on OK. Now, so let's seek for classification data module. Rule is shown over here. Now, if I go back to the file system 2, if I go up here, does the file appear a secret within it, whereas sample file 1 does not, nor does sample file 3. Back into FSRM tool, I could create a classification schedule, so it periodically will, in this case, see confidential information, or I could run classification with all the rules right now, which I do for demonstration purposes. And I'll leave it on the run classification in the background and click OK. Now, if we were about to go back to file system, click on OK, sample file 2, go into this properties and go to classification, we would see that the confidentiality level is now set to yes. So if we go to the classification, so it's just set to none. So instead of manually scouring potential millions of files, you could just have this automated. And I did it mention that instead of creating local property like this, it's called confidential, which applies to a single file server. What if I got 100 file servers and want to use this confidential? We would want to do the same 100 times in defining in the property of each server. So we could go do it in turn centrally in Active Directory from the start menu under the administrative tools. I'm going to choose Active Directory, administrative center. That's because you can define like centralized Active Directory properties over here. To do that, I would click on the dynamic access control on the left, and I would choose the resource properties on the right. We have a number of properties over here that we can choose to right click and enable. That would show up on all the domains joined computer. Notice we have one here character called confidentiality, but I'm going to create my own custom new resource property. So over here on the right, I'll click new resource property. I'm going to call it confidential. For the value setting is going to be yes or no, kind of like what we do locally in a single file server, and I'll click OK on the bottom. So now we have confidential that shows up here, and if I click on it, notice that we don't have the option to enable it because it's already been enabled. To create it, you need to disable it, and that's why the icons look a bit similar. It looks like kind of colored gray as opposed to light gray in the circle. So if I were to go back into file server management tool, let's click on something else over here and click back on the classification, maybe click refresh over here on the right. So this confidential property here, configure centrally in Active Directory, will become available for all the file servers joined on the domain where file server resource manager is installed, and so then it could be used in that manner. So there are many tools out there, whether you are on-prem based like this or cloud-based solution, that will allow you to discover data and classify it according to you can protect it, so you can apply the appropriate security controls on it depending on the nature of web application will determine what kind of data it results in. And so this might be an absolute requirement, maybe a contractual or regulatory obligation for compliance that you must put in place. We know that the classifying of data is important, so that we know if we have in a sensitive data where it resides, and this will facilitate the application security controls to protect the data. Sometimes this is absolutely required for compliance laws, regulations, perhaps security standards, or even contractual obligations, or have the correct security in place. In this particular case, we are going to look at something called Amazon Macie, and at this it is located in AWS in cloud to discover and classify data, so that we know if we have any sensitive information that is stored in the cloud. To get started, in AWS Management Console, in the search field on the top, I'm going to search for S3, and I'll click on S3. And S3 bucket is an enterprise storage in the cloud, and I've already got a bucket over here called the bucket HYZ1, and in the East US region. This is always important to when it comes to data sovereignty. So where does the data physically exist? Because that will determine which laws applies to it. And at any rate, I'm going to click here up onto my bucket, because within it I already have the uploaded files. So what I can do here in this case is enable job in Amazon Macie to basically store through one or more buckets, looking for the data and then determining any of it is sensitive or not. To do that, I'm going to search the data over here at the top, click here on the Macie. Macie, I'll choose the Amazon Macie to open up the console. Now in the summary over here, I have this quick information made about the encryption for S3 buckets, any S3 bucket that might be enabled for public access. But over on the left over here, if I scroll down there on the settings, I can choose custom data identifiers. This is where I can click and create, and I could specify things like regular expressions, and in other words, using special characters for pattern matching. Looking for something that is files have been uploaded in the S3 bucket that I would consider to be secure, such as social security number and so on. Or maybe I'll look for something specific, cost codes or products that would be sensitive information that consists of letters and numbers. So we could build our own customer identifiers. Now the standards like this, like on the credit card numbers and so on, that which will automatically be looked for. So up on the left, I'm going to go back to summary, where I will create a job over here, and I'll click on the job, create job creation. And one of the first things to do here is to choose the S3 buckets that I'll do for looking over here for sensitive information. So I'm going to put a check mark on the bucket that we have looked here. I'll click on the next button over the right and click next again in the bottom right hand corner. And we can schedule the job recurrency. Maybe we want to have a look at a newer modified data, daily, weekly, monthly, looking for sensitive items. Or it can be one-time job, which I will do in this example. We can here then specify the sampling depth. The sampling depth here is set to 100% because we have the same amount of data that I'm going to leave it here. But you can imagine that if you have had, say, about 10 million objects in this S3 bucket, I'll set it the depth to 50%. I'll randomly select 50%, 10 million items to analyze those. Of course, you specify 100% sampling depth if you take longer than if you have simplified 50%. Now under additional settings, we can also add object criteria stored in the bucket, maybe looking for certain types of files and file extension, or the size of how objects are tagged with key and value pairs. Maybe we only want to look at the objects that were modified within a certain period of time. Now if I don't specify numbers or anything in the inclusion exclusion criteria, it says here that the job will analyze all objects in the buckets in accordance with your sampling depth. So okay, so at the bottom I'll click on next, and remember we went and looked in the fact that we could create custom identifiers, and maybe looking for a product with a postcode, something like this. Here's what we are going to identify here. We could exclude or include identifiers data. If we choose to exclude, then I'm looking for addresses or an Australia driver's license or bank account number, or a Canadian passport number, Canadian social security, social insurance number, credit card expiration date, looking for a credit card number. So we can specify which of this data we want to use. In this case, I want to use them all, so I'm going to leave it all over here. Click next. As we saw earlier during the configuration, once we have the option to create identifier, I don't need to do that, and I click next. So for the job name, I'll call it seek sensitive stuff. I could specify the proportional disruption, and then I'll click on the next and right hand button. So we have the review screen for our settings. I'm just going to go ahead and click on down the bottom. I'm going to override the requirement for not having configured the repository. That's if you want to keep long-term storage on your discovery results. I click on submit. Okay, the job is now submitted. So the sensitive information looks like this, and showing the status to be active and running. Now I can click refresh over here, check the status of the job. It won't take long because we don't have any much information over here in the S3 bucket. Alright, and now when we go before too long, the status will change to complete for our job. So I can go and click OK. Before and And before long, the status of our job will say complete over here. So having the that selected over here on the right, I can choose to show the results button and show findings, which opens up in the next window. Now right away I'll find some sensitive information over here, specifically financial strategy, as we have some S3 bucket. We have the bucket name over here, specifically the file within that bucket. If I click on it to open it up, and even shows up on the right that it looks like it found some credit card expiration information, specifically 2 instances. If I click on the link for 2, I actually even have references for the cells. Apparently this is a Microsoft Excel spreadsheet where the information was found, so this is valuable information because it identifies sensitive data, in this case PII. We now have the knowledge that the type of data exists, and we can now put appropriate security controls in place to protect it. If you're using a Windows computer, one way to protect data addresses to encrypt the file systems using encrypting file systems, and otherwise called as EFS. This was introduced as a Windows feature way back in Windows 2000. The idea is that based on the current signed in user credentials, they can encrypt the files where they can sign in again and again. They have the ability to for the transparently decrypt the data by simply opening them, so it is tied to the user credentials. In other words, if a user account can be compromised, well, all the files encrypted with the user account can also be compromised. Interestingly, in Act 80 environment, the domain administrator account is the default recovery agent. They can decrypt the encrypted files by domain joined computer. Now, this is tied to the user, so there are many other encryption systems and they are not tied to the user. This might simply require a passphrase to decrypt, or there might even be a machine that is running on a TPM, a firmware that works in conjunction with the software like Microsoft BitLocker. Those are the disk volumes over here in the schemes tied to the machine, EFS. So let's experiment a little bit with this on my Windows server. I'm going to open the Windows Explorer. I'm going to go to the E drive and got some sample files over here. I'm going to select the folder and right click properties. Down below at the attributes, if I click advanced, I have the option to compress the contents of save some disk space. Well, that's great for saving space, but we have the option over here that encrypt contents to secure. If I turn that on and click OK, I'm then prompted to whatever I want to apply the changes to that folder only, or the folder or subfolders or existing folders. I'm going to choose to apply to subfolders and click OK. So now if I go into the sample files over here, each of these files is encrypted. Visually there is a tiny gold padlock on each icon, but we could just right click on the files and go to the properties, click advanced, and indeed encryption is turned on. So it's encrypted for the current user logged in. Now that I've switched over to Windows 10 computers, specifically Windows 10 Home, the reason I've done this at this point of life because some Windows editions, especially the desktop side, do not support all features like EFS. So if I were to right click over here, go down properties, down the bottom, click attributes, advanced, compression option. Compression is an option because it is an NTFS file system, but encryption is grayed out, so it's not available on some editions of Windows OS. Back here on my Windows server, I'm going to go to cancel out all of these screens. Now I can go to the have like to encrypted files in the same folder and not others. For example, I want to decrypt. So a set of file, right click on properties, go to advanced, just remove the check mark. Okay, it's no longer encrypted. If I were to create new file here, and let's say I create a text document, so I'll get call sample file 4 and press enter. We'll notice that the newly created file is automatically encrypted, and that's because EFS is enabled, in which I've created the file. So it's no longer encrypt the existing files, but newly encrypted files that are created, and the copy and the location will be here. Alright, now I go down to properties over here in the advanced button where it's encrypted, and the details button on the right hand section of the encrypted option becomes available. If I click on details, it will show me who can access the file. I'm currently logged in as an admin for an Active Directory domain controller and shows that I'm able to access the file. The domain admin is also the recovery agent and can recover these files any domain joined computer. Notice that we have an add button here. We could add additional users given here and have the certificates in our multiple admins should be able to decrypt it. Well, this is how you could go about doing that. Now, depending on the nature of the web application you'll be doing to determine whether you will use EFS on a Windows-based system or a server, and remember that encryption is tied to a specific user account, and that may not be the solution you're looking for. So if, example, the result of your web application writes new files to web server disks, records in a database, and you want it to encrypt it for a particular user account. Now with EFS though, we can also work on the command line. If you open up the command line environment, I'm going to go to E drive and going to change the directory, that's sample files over here, and I've got my sample files shown here. If I were just to type the cipher with no parameters, it lists each file with capital letter E, meaning that is encrypted. There's also a note that at the top it says new files added to the directory. That would be E sample files will automatically be encrypted. What I could do though is change the encryption attribute. Let's say I ran a cipher /d for encrypt sample file /txt, okay, and that was decrypted. But if I just type cipher and press enter, notice that the sample file for txt now has a capital U to the left instead of capital E. It's been unencrypted. So we can manage EFS encryption attribute for files and folders and the command line using the cipher.exe command line utility. In this demonstration, I'm going to encrypt data at rest on a Windows system or using Microsoft BitLocker. BitLocker is a software encryption solution that can be used in conjunction with the TPM, the Trusted Platform module. This is normally a firmware chip that there are various ways to virtualize it with things like VMware. But the idea here is that the BitLocker is used to protect the data at rest. Though the encryption where the encryption is tied to the machine, where the TPM is, it's not tied to the user like EFS is. BitLocker can also be used to verify startup integrity on a disk or the operating system to make sure the startup environment hasn't been tampered with. So to get started with here, Microsoft Server, I'm going to start menu server manager. The reason I'm doing this is because, for example, in the start menu on the server, there's something called BitLocker. I have a manage BitLocker option over here, but it's kind of grayed out. When I click on it, it doesn't do anything because the feature is not installed. So here in the server manager, I can install the server-based features. So like I could go ahead and in the PowerShell command line using the add Windows feature utility, I'll click on the next and I'll keep going to the past server where I want to install it, which is the current server where I'm performing this action. This puts me on the roles screen. BitLocker is not a role, it's a feature, so there's nothing here in the roles. I want to change. Click next. Here on the feature screen, this is where I can enable BitLocker drive encryption, where I can see and if it asks for some additional tools installed. So I'll just accept, clicking on add features. So you can try to install BitLocker in the network unlock feature. If I want to use the network unlock key mechanism to unlock BitLocker protected drives in the Active Directory domain joined computer, this could be useful if you have to do some kind of maintenance on machines during non-business hours. But I'm not going to do that. I'm going to just go ahead and enable it. BitLocker drive encryption, and I click next. And I'll click install. It's going to restart the server, so I'm going to go ahead and close the installation on the screen, restart the machine. All right, now I've restarted after being installed the BitLocker feature. Let's go into the file system of the server. Here I'll got the drive letter E, which in a separate disk, and which I have some points over here in sample files, and I go to the sample files of the folder. So I want to do this and I want to enable BitLocker on the drive E. So I'm going to go ahead and right click on the drive E on the left hand on the side of the navigator. I'm going to choose to turn on BitLocker and ask how do you want to enable the unlock feature to decrypt the drive, or we could select use a password, or we could use a smart card on the machine to read the smart card. We could simply have it to insert the card and you'll be able to unlock. Of course, this would need normally a pin to do that smart card feature, but in this case I'm going to use the password to unlock. I'm going to specify and confirm a password. I'm going to click next. Now I need to save the recovery key, so in this case I forget, in case I forget the key, I need I still need a way so I can go ahead and save the file to print. So I'm going to save the file and I'll click next. I'll stick on the default settings of encrypting the disk space, which is quicker than decrypting the entire drive. So I'll go in normally compatibility mode, and in this case the drive were to take a note of the host and place it in the different environments, so running an older version of Windows. So I'll click on the next start button, encrypting. Depending on how much data is there on the drive, it'll determine how much it takes for BitLocker to do this. Even though it's hard for to see it visually, there's a tiny gray padlock drive button in the left hand indicator. If you were to click on the right hand side, if you see the option of BitLocker, so if I choose, maybe if it suspects that something has been compromised, I can always choose to manage BitLocker, where for a drive letter E is showing as being on, so I could choose the backup recovery key again, where I had the option to change the password if in the context menu and remove the password, add a smart card, and the fact that I could turn on auto unlock and turn off the BitLocker. Now what I want to do is observe the behavior once I restart the machine. The BitLocker is designed to protect the data at rest. So in the web server, for example, if a malicious user were to physically steal a BitLocker encryption drive to insert into another machine, then they don't have the password or the recovery key. They won't be able to get into it. So let's reboot the server and see what happens. Now that I've enabled the BitLocker in the drive, okay, so now I've signed back in. Let's go ahead and check the file explorer again. Now look at E drive. I click on it. It doesn't show me my content. Instead, it prompts me to enter the password and to unlock it. Now, if that were an operating system disk protected with BitLocker, the machine wouldn't start unless I enter the password to unlock it. And there is a way to get around it. That's making sure that the TPM chip on the machine, TPM can also be virtualized with various VM platforms like VMware. It's like a virtual hardware device, and if I enter the wrong password over here, naturally it will decrypt the drive. So I'm protecting the drive at the rest of the letter drive E, and of course I enter the correct password and then I'll unlock it. Now I have access to the contents of the drive E, so it relates to the web application server. You have to determine which type of encryption solution makes the most sense. BitLocker is not going to be the only choice. There are appropriate, possible scenarios for every possible scenario. However, in many cases, you're going to be dealing with sensitive data, and there will be laws, regulations, and security standards that you must be compliant with to protect the data at rest. Alright, so Wireshark is a free open source network analysis tool. We could also say it's a packet capturing tool. It allows you to capture network data, whether wired or wireless, and then you can go back and analyze that traffic. It might even later be downloaded down the road. You can save the packet at the PCAP file and then go to see if there's any suspicious activity, maybe troubleshoot on the network problems, or to see any clear text credentials that were being sent over the network, specifically so that we can examine clear text credentials that were sent over the network. It's important to illustrate how easy it is to do this, and at least if you can place yourself correctly in the network, to reinforce the fact that we really do need a secure environment or network communication. So for instance, if here I'm connected to the sample sign-in page on a website, however, in my browser on the left hand side it says not secure. If I click here, your connection is not secure. Any information that you enter sensitive might be stolen by attackers, so you shouldn't use this, but let's say we don't need that advice. Instead, I'm going to fill in the username and C Blackwell and same password. Now, before I click login, let's go ahead and start packet capturing session to make sure that we see what that looks like in Cleartext. Once we have captured the traffic and start analyzing it. Now remember, think about the network layout. In order for a malicious user to capture the traffic, they have to be able to see it. In modern network switched environment, the only traffic you see for a physical network switch is that you might be plugged into if there's some kind of network you are in. Only you only see your traffic rather than the broadcast and multicast network. So unless you are using some kind of technique like ARP cache poisoning or funnel traffic through this device, if you're going to be enabled to switch port mirroring to copy all the traffic that you're running into a packet capture, it's just not a piece of cake to capture all the network traffic. So here I've started the free Wireshark tool I've downloaded and installed, and many attackers would use this tool similarly if they would want to try to credentials over the wire. It could be wired or wireless. When it comes to stuff, it's encrypted, that is sent over the network. So I'm going to go ahead and start my Wi-Fi capture, double clicking on it. Now we see some traffic is being sent. So all that means is I'm going to click login here. Now let's say login failed. Well, that's fine. We don't really care about login success or not. We want to see if they've been captured. So log credentials we can send over the network. Here then the Wireshark, I'm going to go ahead and click on the red button to stop my capture file, and I'm going to filter based on IP of the host. That was the form that I was submitted earlier. I'm going to look at finding those credentials, but where exactly am I going to find those? Well, you could see and select HTTPS traffic over here. I'll already see this traffic, and get the request from login PHP. Well, having that packet be selected, let's see what happens here. Click analyze and follow TCP stream. Immediately I'm going to see the credentials, and it doesn't take very long to follow through the session, and I see this in case the username and password was submitted. This C Blackwell password was submitted as test123. Now we don't want us to be lured into the false sense of security that this is an internal web application that runs on the internal network, and thus we don't need the HTTPS. We want to use HTTP at all times, even internally, because we have to think about a concept of the zero trust, not trusting anybody or anything, even internally on the network. We might have a malicious internal user, a disgruntled former employee. We might have an innocent internal user that has a malware infection on the machine to be able to capture the network traffic like this. So there's a never good option to use plain old HTTP. You might be submitting sensitive information to login credentials over the network. But let's say we change the filter here to TLS. So encrypted data basically over the HTTPS. If I select only those packets, let's say we have a breakdown of the TCP header a little bit over here. I see the source port is 443, so I'm telling me unless that I'm spoofed traffic. The traffic is coming from web server. We could click on another transmission until we get to the point where the destination port is 443. That could be secure traffic being sent to the server over HTTPS, so the destination port is 443. Okay, well, what else can we see here? Anything interesting? Well, we have a transport layer security header, so we can look at that, and that's not really too much that we can glean from that, other than the fact that there are some encrypted data from HTTP over TLS. And so instead of seeing plain text transmission down here, the payload, or if we select the packet and again go at the analyze, follow TCP stream, it looks like some jumbled up tricks. In other words, scrambled data, encrypted data, which is entirely the point when using HTTPS to connect to the web application server. In this demonstration, I'm going to be enabling an HTTPS binding for Microsoft II's web server. We know that HTTPS is absolutely critical in protecting the communication channel between the client and the web application. And in order for us to enable HTTPS, we must have to have the PKI certificate. So let's start with that. Here on my Windows server, I'm going to go ahead to my command prompt cmd. I'm going to go to here and type mmc to launch the Microsoft Management Console. Now that the mmc is basically an empty administrative shell where you can add snap-ins for the portions of the OS which you want to administer. So do that. I'll go to the file, add, remove snap-in. I'm interested in certificates right now, so I'll click certificate. I'll add what I want over here with certificates and the local computer component. The local computer is where I have already installed the Internet Information Services IIS. So I'll choose next and finish OK over here. Alright, so what I want to do on the left hand navigator is go down under certificates and personal, and then click on certificates. We've got a number of certificates shown over here and the name of the subject, such as the common server name versus the full DNS name. And so we have got the issue of the certificate, the certification authority. We have the expiration date of the certificate and the intended purpose of the certificate. So I've got one over here for an intended purpose for the server. Authentication and expiration date of that certificate is in the future. So it's not for DNS. Name is not lost. Name is of my host. So if I double click over here in the certificate, I also see the private key that corresponds to it, and that's important because your PKI certificate that installed the web server has a public key and a private key pair stated in the simple terms over here. I'm going to transmit the public key from the service PKI certificate to the client device. Now the client device will use to encrypt a transmission to the server. That will be the transmission of the unique key generated by the browser, and the server can decrypt the received message with its related private key, thus exposing the unique session key from this point onwards to secure the connection for HTTPS. Anyhow, I'm going to click OK. We know here we have a good certificate, so we are good over here. So I don't want to save in my MMC console. I want to do this now on a start window, machine, administrative tools, and I want to fire up my IIS manager tool. I've already installed the IIS web server role on the host, but that wasn't already installed. I'll go ahead and install it, and after I drill down on the left navigator, I'll go to the sites, and I've got my default website. I'll click over here and choose edit bindings. Currently it does not have binding on port 80, so let's go ahead and take a look at the IP address in the command line. Here with the IP config 192.168.4.167. This host actually has multiple network interfaces, so you could go ahead and choose to bind the web server, either one of them or all of them, default by all. So if you go to web server and then put in the IP, I get a connection to the default page of IIS, but it's all happening over HTTP, which means nothing is encrypted for that connection. Now in this case, we haven't authenticated the web application or not accessing any sensitive information. However, the standard these days is to go have an HTTPS enabled on web application. It's easy to configure. In fact, some people might shy away from websites that don't use HTTPS if you don't have to authenticate or access the sensitive information. So it's not worth doing. So let's flip back in the IIS manager. We are looking on the site bindings. I'm going to click OK and add bindings. Here I can choose to appropriate IP address details by default. The binding applies to all unassigned IP addresses. HTTPS connection normally occur over TCP 443. We could go ahead and change that to default. Select it over here. Down at the bottom, I choose SSL certificate. That it itself is the misnomer. Now SSL is deprecated, and it's just the network security protocol, just like TLS. Transport layer security supersedes SSL, but it's not a TLS certificate, even though often though it's called so. TLS is a network security protocol that we can use it. Technically, it's a PKI certificate at any state, and doesn't really matter from the top down. What we understand here is that doing so, we are, why we are doing it. And in this case, we select the correct certificate. So I'm going to go ahead and select certificate over here. We need to make sure the certificate is valid as a private key. Now in this case, it says at the top of the certificate can be verified. So trusted certificate authority, it's a self-signed certificate, so it's not trusted by the operating system. So we could add a public root certificate for that CA, and that would, so it would be trusted. But now we are doing, here is it for demonstration purposes only, so I'll just click OK and leave the ATS binding, although I could technically select that it and remove it so that only 443 is available. I'll click here. Let's test it out in a web browser. Back here in my web browser, I'm going to go ahead and click on the refresh screen. So trying to connect to the same page over HTTP, but this time it says that you cannot reach, right? HTTP binding makes sense, and let's change the address bar over here and put HTTPS, and let's put enter, as you might expect, same as well. But there's nothing to secure, so we don't trust the issuer of the server certificate. We expected this. If I click on more information, we can still go on the web page, which I will. So we're going to have a connection web application HTTPS, and of course in the web browser at the right hand side, corner certificate error is what I get. If I click on it, view certificates, the same thing we saw before. It can't verify the issue of the certificate authority. So if you're going to be doing this in an internal network, maybe for a line of business or web application used for your employees, you're going to need to install the CA certificate authority certificate and on all client devices. Otherwise, they are going to run into the same issue. All right. IPsec or IP security is a collection of network security protocols that allow you to, secure your network traffic. Now that might sound like a lot using HTTPS or web application, but the difference is that the HTTPS is specific to HTTP web server traffic. IPsec can be used to encrypt any type of network traffic, including all network traffic. Even ping traffic is also an string traffic or FTP traffic as well. Here in my browser, I've done a simple search for IPsec LAN, and immediately we have numerous hits on how to use it to a secure server and network. Now you might wonder why this would be interested in using IPsec or LAN. We would be talking about the web application. Well, who's to say that the web application wouldn't be, using an internal network or an intranet? Maybe for a line of business or employees, it isn't something that would be normally used over the intranet, securing web applications over the internet, or normally doing so over HTTPS. But remember, you need to secure the entire ecosystem where the web server resides, and this is one of the ways to do it internally. I'm going to go ahead and do this in the start menu over here. I'm going to type firewall, and that will bring me up the Windows Defender firewall with advanced security. Now, of course, Windows Defender firewall can be used to define the outbound inbound rules to allow denied traffic. But it's also got connection security rules. Now we could go right click and build the connection security rule to determine the IPsec how the IPsec should behave. Now we're going to go on this host. We'll only configure IPsec on this host. However, we can also do centrally using a group policy, which could potentially affect multiple computers joined to Active Directory domain. So from the start menu, let's open a group policy management tool. We're going to go down into the Windows administrative tool, and then the G. From here enough, we'll reach the group policy. Every AD domain has a domain policy, and that's the group policy, or GPO in short. And that could potentially be managing thousands of these settings now linked, associated with the domain. So by default, it flows through and goes down the organizational units, OU, unless you have an organization or OU, what we are doing over here. So that's got the inheritance turned on. So if I right click over here, block inheritance, which means that you do not allow the GPO settings to be above to be inherited in this OU. And in this case, where we are going to configure the IPsec connections to security rules, that's going to be under computer configuration. You'll have to expand the policies. I'm going to go to the Windows settings, and over here, go to security settings. This is where you have the majority of your Windows settings. configured in the GPU at the computer level, as this was opposed to the user level. So the computer that has joined the Active Directory domain, I'm going to go down under the Windows Defender Firewall and Security Advanced. Just keep drilling it down under here. We can see, specify inbound and outbound rules, such as that would call the individual host. We can also configure connection security rules. So the difference here is, by default, these rules will apply to computers in the domain, of course, except where block inheritance has been turned on for the OU. So I'm going to go ahead and right click over here on the connection rules and click new rules. Depending on the requirement, will determine what type of connection you select here. For example, I'm going to go ahead and just choose server to server, and if I want to authenticate connections between specified computers, so I'll click next over here. It asks if I want to go to a specify IP address at the end of the connection, so we can go and specific IP address that we could do over here, affected, so that these will get settings on the other words. And I'm going to leave to any IP address. Then we can have the option how do you want to protect the IPsec negotiated. We want to do it for inbound and outbound connections to require it for outbound connections, but request authentication for outbound, we require inbound and outbound. Now, by requiring for both inbound and outbound connection, this means that the hosts affected by this group policy and these connection security rules, they will only ask for to talk machines configured similarly. Now, I have a highly secure environment that might make sense, but if the machine, for example, needs to connect to an internal host, that could be a problem if the internet host is not configured but with the same IP. It's like connection security rules. I'm going to go and choose those inbound and outbound. So if the machine that is communicating with the server affected by this doesn't support IPsec communications, will start in place, and after checking to see if IPsec could be used. So I'm going to go back and click on next. Here we can use the computer certificate to authenticate the machine. Click on advanced over here. Similarly, I've got two authentication methods. I'm going to go select the second one that kicks in. I could go ahead and select. It can be computer Kerberos version 5. Now that's the Active Directory authentication protocol. So for domain joined computers, that's a good advice. That's already been implied over here, the trust level. By virtue of the host joining Active Directory, you can also use the older NTLM version 2 protocol PKI certificate, so you can use at least secure option of the pre-shared key over here. All right, but because in this case you would want to applicable to the entire domain joined computer, it makes sense to use Kerberos v5. I'm going to go ahead and just continue over here, specifying network location profile that applies to. I'm going to leave it selected for all, whether it's domain joined or not, an Active Directory domain network or a private network or a public. In this case, for example, servers don't get carried away, moved around, so at least identically it wouldn't be. So that probably isn't an issue over here. This is going to be a request for IPsec, and I'll click finish. Now at this point of time, I've got that all configured. Let's switch back to the details screen. Now we have got request IPsec. I've got enabled the group policy. Now remember, the group policy has to refresh before we can expect to see changes on the machine in the domain. So if I were to go back to the Windows Defender Firewall, look at the connection rules, I don't see it here. But if I go to refresh group policy, so let's go to command prompt, GPU update force, so it manually just tries to test it. You wouldn't want to run this on every computer on the network, nor you would want to remote into them. It'll just happen automatically. Normally the refresh interval is approximately between 60 to 90 minutes. Now that group policy has been refreshed. If we check Windows Firewall, or if it's the individual firewall to request IPsec connection rule type, then we have a session that has actually been established between the two hosts, and the IPsec would be under monitoring. Now if you were to capture IPsec traffic, which I have done here using the free Wireshark tool, and then let's say the filter and the traffic for ESP encapsulating security payload, I have a number of ESP packets shown over here. Now if I select one of them, go down the packet over here. I have got my standard Ethernet header with the source and destination MAC. I've also got the IP, which has my standard IP address information among those items, so the source and destination IP. But after the IP header, depending on the traffic, I might expect to see maybe TCP and UDP header, but I don't even know what type of traffic this is, because what follows is ESP. So I've got my encapsulation done here, where an entire original packet has been encapsulated and the new header has been added. So in this way, the traffic is all protected, well, for now. And this could be an FTP traffic, but due to the ESP encapsulating security payload mode, I don't know what I don't know what it is, and so the traffic is completely secured. In this demonstration, I'm going to encrypting the cloud storage and Microsoft Edge Azure using the key vault. So I'm going to be creating two resources here in Azure. Going to be creating storage account, and I'm going to be creating key vault here. In the key vault, I'll generate a key pair that I can use to encrypt the storage. So I can get started with the Azure portal by clicking on create a resource. And I'm going to set up a search storage account. I'll select that, and then I'll choose create. In some fields over here, I'll see the subscription is to create this account and the resource where I want to deploy into. And of course, ultimately the storage account name, I'm going to call it the store cap app 782, and I'll deploy it in the Eastern US region. I'll accept the defaults for everything, but I've kept the click on encryption option to be a peak at default. Default setting for the storage account is that I'll be encrypted and accept it'll be encrypted in Microsoft managed keys. And now sometimes regulations might stipulate that you might be in control of the decryption keys for data and are protected by encryption. We'll change that after the fact. That for now we will leave it on Microsoft managed keys. I'm going to click on review, and I'll click on create button. All right, before the deployment will complete, I'll go down the next steps, click on go to resource, open up the properties of the storage account. There are really 4 types of things that we need to do in the Azure storage. You can build blob containers, which are like folders on the disk, and then upload blob, which are essentially just files. You can upload files on the server on the cloud and create shared storage, and you would like to be in a Windows file server. You can work with the cloud queues will be in the interest of developers, where we can have the software components drop messages in the queues, and then will be picked up from here. And then you can also work with the basic key and value and storage management. We're going to get involved content of the storage over here, but let's assume that there's some content we want to protect in customer managed keys. So I'm going to click on home link over here, and I'm going to click here create resource. And again, it's time to going to be a vault key, and I'll click on here, click create. So in Azure cloud, the vault in the central storage location, a secured storage location, of course, for the secrets, things like username, password, and the PK encryption. So I have to create a vault that will store the passwords things over here. So I'll create over here pay as you go, RG1 KVA PSD is the name, region US, and pricing tier would be standard. Premium would be something you want to go if you have a HSM backed keys, and then which is like a hardware appliance which is tamper proof, so cryptographic keys can function and perform cryptographic operations. So if you have regulations that require security keys, so you might want to choose premium. I don't need that over here, so I'll stick to the standard. I'll click review, it'll run the validation. Okay, so when the deployment is complete, I will go to the create resource button over here, and what I'll go to starters to access the policies. We want to make sure that we have the access for the account storage. You want to make sure that we have access to the vault in this key, and our name down below over here. secret and certificate permission. So let's go ahead on the left click keys, and we are going to generate an import. I want to generate a key pair, so I could import keys, and already have I can restore them over here. But I want to generate a new one, so I'm going to go ahead and call it a storage key. I'm going to be choosing the RSA 2048-bit key. I'm going to go ahead and select the activation and expiration, but I'm not going to bother. I just want it to be available now. Yeah, and I'm going to make sure that the key pair is enabled, and I'll choose create. Now we have our storage key account, and the left hand side navigator, if you go to storage accounts, I'll open up the storage account we have created. As I scroll down on the left, the security networking, I can choose encryption, and this is where it's currently set as the Microsoft managed keys. While regulations might require us to use keys under our control, well, we have already got the key and the key vault. We also have the point from it, so I'm going to go ahead and choose the customer managed keys and down below. So I'm going to click on the link and select key vault over here. So I'm going to choose the key vault. I'll choose our key from the end of the list. I will choose here storage account selection, and down below it's going to create a system assign manage activity. That's an underlying Azure Active Directory object that represents the storage account where it can be given permissions such as access key from the vault. So I'm going to go ahead and choose save. After a moment, the things have been set up successfully. We can verify this by clicking on the bell icon. The upper right hand corner has successfully updated our storage account, and we are currently using a custom managed key of our key vault to protect data at rest in this cloud-based storage account. So in this course, we have examined how to put security controls in place to protect sensitive data in use, at rest, and in transit. We did this by exploring cryptographic failure attacks, and we discussed about PKI hierarchy. We also covered PII and other common data privacy standards that apply to sensitive information. We classified data with Microsoft File Server Resource Manager, otherwise called as FSRM, and as well with Amazon Macie in the cloud. And then we encrypted the data with the encrypting files system in Windows with Microsoft BitLocker. We also captured HTTP Cleartext credentials. We enabled as an HTTPS server binding. We configured IPsec, and we encrypted cloud storage as well. So please do remember to check out the A03 in the OWASP top 10, which is next up on the list. Thank you all for watching this video. I have a great learning session ahead. Bye now.